In this lesson, we'll properly explore atomic vectors. You've already worked with them since the beginning of this course, but now we'll take a more structured approach. We'll start by creating atomic vectors again and performing operations on them, just as we've done before, but with more depth. Specifically, we'll learn how to assess individual elements of a vector, understand the concept of indexes and indices, and finally, modify elements by adding, altering, or removing them. To create vectors, we use an example object you are already familiar with, our fish-themed data from earlier lessons. I also introduced scalar objects, which we touched on in the previous lesson. You can think of scalars as the atoms of data structures, and we'll now use them to build our vectors. Let's use my favorite fish, the mackerel, also known as Titus in Nigeria. It's a delicious and sturdy fish. You should try it if you haven't already. You can print this favorite fish by simply calling the variable name. Then use the length function to check how many elements it contains. You see it's just one. You can combine values using the C function to create a new variable called fish type. You can check its length as well to count the number of elements. As we said earlier, atomic vectors represent data types. Let's now create another variable called mackerel weight with a value of 500 grams. You can perform operations on this vector, like adding a number to it. For instance, if I want a larger fish, I might add 3000 grams. Let's say I want to change the appearance of the fish name. Instead of lowercase, I prefer it in uppercase. That's another operation we can do on vectors, text transformations. Now, let me show you a little quirk of vectors. If you try to combine different data types in one vector, like the name of the fish, its weight, and a logical value indicating whether it's my favorite, we'll create a vector called fish details. This vector contains the name, mackerel, which is a character, the weight 500, which is numeric, and a logical value true. What data type do you think this vector will have? Once you run it and check the class of fish detail, don't be surprised to see its character vector. That's because vector in R can only hold one data type at a time. When multiple types are present, everything gets coerced into the most flexible type, which is character. Character values can represent anything, so R converts all other types to character when mixed. Now let's create a new vector called fish detail 2 with just 500 and true. This time, when you check the class, it will be numeric. Why? Because logical values true, false can be converted to numbers 1, 0. If you check the type, it will be double. So here's the key takeaway. Atomic vectors in R can only store one data type. Whenever you try mixing types, R coerces them into the most compatible single type, following a specific hierarchy. If I printed the original fish detail, you'll notice everything is wrapped in quotation marks, confirming that it's been converted to character.